Welcome to Tales from the Rabbit Hole. I'm your host, Mick West. My guest today is Stian Arnesen. This is episode 4. Episode 3 was where I first talked to Stian, and this is a very large excerpt that I removed from episode 3. So make sure you listen to episode 3 before you listen to episode 4. There's a bunch of technical things in this episode because we talk a lot about the science behind the collapse of the World Trade Center. But that mostly happens in the second half hour, so if you just want to listen to some interesting talk about conspiracy theories and debunking, the first half hour is very good, and if you're interested in the science of the collapse of the World Trade Center and how to talk about it, listen to the second half too. We start out talking here about the Alaska Report, which is a report carried out by Dr. Leroy Hulsey at the University of Alaska and a couple of his graduate students that was paid for by Architects and Engineers for 9/11 Truth, which is a group that promotes the conspiracy theory that the World Trade Center was destroyed by explosives. This report has been in process for a number of years and is just on the verge of being released. A couple more things I want to touch on. What do you think is going to happen with the immediate future of the 9/11 community? Do you think it's just going to go on exactly the same? Because there's a number of irons in the fire, so to speak, with the studies and the lawsuits and things like that.
Yeah, well, it could potentially lead to some unintentional consequences, I feel. When talking to one of the peer reviewers, what they've done in the Alaska report that I got to know today is that they've done an entire simulation of the collapse of Building 7 from the top down, and they've with the report being released, hopefully before the summer, they have done modeling where they've taken out certain sections of the building and done the same as in the official World Trade Center 7 report and tried to simulate how things would happen, and also simulated, according to him, that what would happen if all the core columns would have been taken out instantly. So they've gone through a lot of different scenarios to exclude the possibility that the official story is true. And they're hoping to get the report within a couple of weeks for peer review. The reason for the delay has, according to him, been because Leroy Hulsey has been injured in an accident, and they've had to change a bit of the rhetoric in the report due to the language being used in it. And I think that with that report coming out, there can be some healthy questions that could hopefully bring up some new questions that could lead somewhere. And I will, of course, notify you as soon as I can when that report becomes available in any draft or in any way, because I think the more minds look at it with different classes, the better. But with the future of the 9/11 community, I think that it will be. I think it will depend on the Alaska report and the lawsuits coming up.
So what did you mean by unintended consequences?
The reports could maybe lead to questions being asked that hasn't been asked before in the engineering communities. The idea is to spread this report far and wide through all different kinds of engineering and architecture and communities to have the most amount of people look at it. And if the report shows what he says it will show, that there's no way that this building came down the way it did because of fire, then I guess the unintentional consequences could be anything, really. I mean, it could be potentially an uprising for a new investigation, or it could be something else that I can't even imagine, because if it does come out that there's no way, then I can only speculate as to what will happen. But I don't think it will die out.
Yeah, I certainly don't think it's going to die out either. It's one of those conspiracies that's obviously it's been 18 years now,
It's like JF.
and yeah, it's going to like JFK will that conspiracy theory will live forever. Uh,
Mm,
but I think maybe one of the consequences you mentioned was people looking at things they hadn't looked at before. And one of the challenges I have in debunking things is that the mainstream scientific community doesn't really take things seriously. So it's kind of hard to get people to look at chemtrails. Like I was part of a study where we asked scientists to look at chemtrails,
mm,
supposed chemtrail photos, and we surveyed all these scientists, like hundreds of them, and we got a lot of responses back. People saying, "Are you serious? Like this is just ridiculous. Why are you even doing this?" And people didn't even
exactly.
respond a lot of the time. And
Exactly.
then there was some proper scientific names associated with the study, so we did actually get some responses. But it's very hard for people to take things seriously. And I think
But why do you
from
think that is?
well, because chemtrails in particular, I think a scientist, when told, the government is secretly spraying things out of the back of planes, and the evidence
Mm,
is these white lines we see in the sky, they'll
mm,
just say, "Well, those are contrails. What are you talking about?"
mm,
And it immediately, on the face of it, falls down. And I think
mm.
most people
But they,
in the,
that, sorry.
I
Well,
think,
we know that they have experienced or experimented with chemtrails as a way, or not directly chemtrails, but contrails as a way to perhaps stop global warming or to cool the planet in creating artificial clouds and putting chemicals into this to make it
Mhm.
more intense so that it would do whatever it needs to do to cool the planet. So the idea that the government would be spraying something, to put it like that, into using planes to do it, one would think that a scientist or the people that you approached should instead say, well, let me get back to you on this and let me
Mm.
look at it instead, to have an
Well,
open mind.
the people that we contacted were people who were experts in their field, and there was two areas. One was atmospheric physics, which is basically clouds and things, and the other one was atmospheric chemistry, which is the things that are in the air and the deposition of those things out of the air. So they are familiar with what's actually going on in the sky,
Mm,
and they know
mm,
that the trails are contrails, and they know that there haven't been any you know large amounts of aluminum being found in the air. And also, we didn't just ask them; we sent them a questionnaire, which gave them the
mm.
opportunity to look up things, and so they could look up what the
Yeah.
state of geoengineering research is right now. And the state of it is that no tests have been done spraying things
Oh,
from planes. So we're at a
okay.
very, very early stage in potential geoengineering research, and because they know that, they're just going to dismiss it. I think a lot of people also are quite dismissive of conspiracy theories in general. The idea that the government is secretly uh, doing this enormous project, spraying thousands of tons, tens of thousands
Mm.
of tons per day, just seems ridiculous to a lot of people. Now, I know it also seems perfectly normal to a lot of people because they are more prone to believe that the government does these large-scale secret projects. I think going back to
But
9/11, though, it's like you get the same reaction from engineers and scientists and pilots when you talk to them. They will either just reject it out of hand because it just seems so ridiculous, or they will
mm,
know something about it, or a combination of both those things. And so
mm,
they view 9/11 conspiracy theorists, like no offense, as being from their perspective like tinfoil hat type people, and that they
mm.
don't even think they deserve any of their time. So if we wanted to get a proper refutation of the architects and engineers for 9/11 truth, it's left to people like me or like the other people who aren't really engineers to
Mm,
go
mm.
through these things. And so we get these debunkings that really don't carry that much weight, even if they're correct.
But that phenomenon in itself, of that way of reacting to, I mean, the idea of there being a conspiracy being true or not true should either way have be open for discussion or debate at least. I mean, the idea that it doesn't have to be the government, let's say. It could be a privatized institution or company, or it could be several companies. It could be privatized or maybe privatized and government interest cooperating to achieve a common interest or a common goal. And regardless of how, I wonder where that phenomenon or psychological phenomenon in people come from, where they have that reaction, as you say, that, oh, this is so ludicrous, I'm not even going to touch it. Where in some cases, these things that sound so ludicrous, for example, what Snowden revealed, or what Julian Assange has revealed, or go through history, through the Roman Empire or anything else, you see this as a human phenomenon to collaborate or to achieve a goal, and you're willing to go at any length to achieve it if you're ideologically rooted enough to, and then do it. So I wonder why so much resistance in people and experts, so-called experts, where they don't even want to look at the material. That's when I have a problem with it, because they're the ones responsible for answering the questions about this, because they're the ones that know something about this, and they're the only ones that can tell us how we're wrong. And when they have a reaction like that, it just builds up the inertia of people that believe that there's definitely a cover-up. And so I'm I'm paralleling it here to the way that these scientists are reacting might be familiar to almost these small groups, families, where they have their worldview threatened. Because what if they're actually right? What if I'm, for example, in the 9/11 community saying that maybe it's not the way you think it is? Oh shit! Well, then we're going to exclude you, and we're not going to listen to you. You're a shill, or they name call you, just like they do with tinfoil hats, or it's the identical behavior, in my view. And where do you think this phenomenon comes from in people?
Well, I was reminded there with some of the interactions I've had with flat Earth people and talking to people who are not flat Earth people. And, obviously it's a far more ridiculous conspiracy theory than even chemtrails or 9/11. But you get the same reaction from ordinary people. Like if you say, like, I believe the world is flat, then they are going to say, that's just ridiculous. That's just complete nonsense. I'm not even going to bother talking about that. But if you ask most people, how do you know the Earth is flat? How do you know the Earth is round? They won't be able to give you an answer. They're just saying it because that's what they've learned in school, and they trust the scientists, and and people make fun of flat earthers.
Yeah,
and I think there's obviously going to be a degree of that in any conspiracy theory. If you say, like, why don't you believe in chemtrails? The initial reaction of a lot of people is that's obviously ridiculous. And with 9/11, everyone saw the planes fly into the buildings, and we saw the buildings burn, and we saw the buildings collapse. So it doesn't seem that unreasonable to most people that that's what happened. And then you got some other people like saying, oh, maybe there were pre-planted explosives, and it's because we can see these squibs and it didn't fall at the right speed, and this flange was 2 inches too wide. That just sounds like a lot of, to most ordinary people, it just seems like an unnecessary made-up complication to their simple explanation that they already have, that they think most people share, and that they bought into at the time, and that we justified going to war over. And so they just reject it out of hand. The vast majority of people are not interested in the science behind 9/11, like in the way they're not interested in the science of whether the world is flat or not. They just accept the official story, and I personally think that they are correct in that general assessment. Certainly with the physics aspect of it, but. I would like to have more physicists weighing in on why the towers collapsed and why Building 7 collapsed the way it did. I was thinking like the chemtrail paper I helped out on was called An Expert Consensus on a Secret Large-Scale Aerial Spraying Project. And it's basically a consensus paper where you try to figure out what all the scientists think on average. And I think we could do something similar like to that with 9/11. If you could somehow manage to take a survey of actual engineers, I think that would be an interesting way of getting a better gauge. Because right now all we have is that we have these thousands of architects and engineers for 9/11 truth on the one hand, and then we've got like a vast silence on the other side. Now, really, that vast silence is because these people are going, "Oh, that's just ridiculous. Why am I going to bother with that?" But to the people on the truth side, they think that these people, they're scared of losing their jobs, they're scared of being ostracized, they don't want to look at it because it worries them.
Could be some truth in that.
There could be some truth in that for some individuals, yeah. But people do. If people start spouting 9/11 truth in the workplace, it can actually lead to problems. But that's just if you start being evangelical about anything in the workplace, then it's going to cause problems because you're not doing your work. You're spending your time evangelicizing and bothering people. But I see your point that people might be, they don't want to look into these things as a conscious decision, maybe a subconscious decision as well. But I would encourage people to look into them. I look into them, but like I said, I think there's one group of truth activists who have a challenge every year where they have a debate, and they put up this one guy or another guy. There's two guys that they alternate between, I think, and they hold this debate every year, and every year the 9/11 people win. Now, the reason they win is that no one shows up to the debate. And no one shows up because all they have is they have an open invitation to somebody with a PhD in physics and who has a certain publication ranking and so many years of experience and has published one paper on building dynamics or something like that. So they got this narrow field of people, which is probably only a few hundred or maybe 1,000 people, and they just announce it on the internet, and they probably email a bunch of them, and people will just put that straight into the bin when it arrives. No one's taken them up on it, but they wouldn't have me on, even though I could probably answer a lot of the questions that they do. Even though I don't have a PhD in physics, I'm familiar with the basic issues. They wouldn't have me on because I don't have a PhD in physics, and so they I don't know if they're justified in doing that because are they genuinely doing it because they don't want lay people on, or is it just a way of artificially restricting the debate people?
I think you have a really bad name in that community, to put it mildly. So
I saw on their website I was called the Pope of Demolition Denial. That's actually something that's on an actual article on Architects and Engineers for 9/11 Truth. The Pope of Demolition Denial. Which I was quite tickled by that. Yes, I know. It's like, what? What does that even mean?
Oh, excellent. But
I suppose it could mean my word is law or something like that. But I know it was quite funny. Yeah, and that's an unfortunate thing as well. Talking to people, I want to be able to communicate with people, but once they've formed this opinion of me as being a shill or whatever they think, a pope, then it makes it very hard to talk to them, and it's unfortunate. I talked to you, and we had, I think, very productive discussions, very honest discussions, like we did today. And I think it was great. I think progress was made, and I have a better understanding of the issues from my discussions with you, and you've probably got something from the discussions too. So I think having these types of discussions is a vital part for everyone to move forward.
I was wondering in regards to, and I completely agree with you there. It's we had a conversation with Richard Gage on the phone a while back,
You and I did.
and
Oh,
yes,
yeah.
with Richard Gage on the phone, and I had an impression that that was productive in a way, even though it wasn't exactly going into the weeds as you wanted it to. But if that was the approach forward, where there could be, I mean, I've been asking myself why the heck hasn't there been a panel where you, for example, and Richard Gage, and having, for example, two independent, structural engineers or whatever, or someone else having a discussion and an interaction maybe with each one's presentation and actually having a productive debate. Why hasn't that happened? Have you taken any initiative to try to make that happen? Have you felt anything from the other side?
No, no one's ever approached me on that. I mean, obviously, I think when we were talking, then it was about the possibility of going on the Joe Rogan podcast, which just never happened because Joe's I think moved on to other things, and that would have been a good talk. I think just me and Richard discussing our differences would be good with someone like Joe or someone like that mediating. Like you say, often these conversations they devolve into the weeds, the details, and it can be a bit boring for the listener. Did you see my discussion I had with Tony Zambotti?
Yes.
That was interesting. He didn't obviously. I didn't change his mind, and he didn't change my mind. But we discussed things, and I told him some things that he didn't know. Like he didn't know that the Gerda 2001 wasn't actually an initiating event in the global simulations, which is a detail that to most people is completely meaningless, but it was very significant, I think, to him, and even to the context of the study in Alaska. So I think having discussions like that can be productive. I think beating out individual details, like, for example, the column that was cut at an angle. If we can agree that that particular column was not cut at an angle, then we can stop talking about it and stop wasting a lot of time. And if we agree that there could be other causes of iron microspheres, but perhaps they think there was so many of them, it must have been thermite, then we can agree that we'll start talking about the quantity of iron microspheres rather than their simple presence. So we can kind of move the conversation forward rather than just doing these old things over and over again, constantly having things like, how can a aluminium plane penetrate a steel building? And then I hold up a picture of a ping pong ball going from a ping pong paddle, and I do that 100 times on an individual basis. But if we can actually, agree on some things, then I think it could be a bit more productive.
Yeah, definitely. After having those conversations with, for example, Tony Samboti and other people in the community, which I've seen you've had, or at least doing podcasts with people talking about much of the same issues, are there any, after doing that, do you feel there are questions around the collapses of the buildings themselves that might have changed a little bit, or that you feel, do you feel that there are questions still about the collapses that are unanswered?
I think we don't know the exact sequence of initiating events for any of the collapses. I think we've got the broad strokes of what happened, but I don't think we know exactly what happened. But I don't think we're ever going to be able to find out because everything happened inside the building. So all we're going to be able to do is get a range of possibilities of what might have happened. With the World Trade Center 7, much was made of this one girder which was on a seat, and the other girders pushed it off in one simulation. In another simulation, they pulled it off, and in yet more simulations, it stayed in the same place. So the initial conditions of a simulation and the assumptions you make about what happened with the fire, which isn't entirely known, will vary the outcome greatly. Now, if you look at the simulations that NIST did, they ran a simulation of the fire, and then they ran a simulation of what damage that fire would do if it had burnt for under 3 different scenarios, and then they took that damage from the resultant damage, and then they put it onto a completely different model, and then they just said, ready, steady, go, and stepped that model going with its damage already in place, and the building collapsed. Which, it was a reasonable thing to do with the technological limits of the time. One run of that building collapsing simulation took them like 3 weeks to do. If they were to do it again now, they could probably make it a lot better, and they could do it a lot faster, and they could do multiple runs. They could farm it out into the cloud and have like tens of thousands of computers running on it at once, rather than just the 5 or 6 that they had running back then. So, we could, if someone wanted to spend a few $1 million doing very detailed simulations, then they certainly could. So I think, but even then, there's a thing, there's the chaos theory tells us that very small changes in initial conditions have huge implications further down the line. There's only a certain number of connections which can fail in the World Trade Center, but we don't know which one is the first, or what led to it. What thermal expansion is going to be completely different all over the place, because there's fire here, there's fire there, that cools down, that dies down, that's a certain distance away from that, there's a bit of wind, these windows are broken, these windows are not broken, these windows broke later at a certain time. It's very, very complicated. So knowing exactly what the position of any particular girder or the state of any particular bolt is something that's not going to be known, not going to be knowable. You can only get the broad strokes. You can say, if this column failed, then we're going to get something that's going to look roughly like this. You can say if this column failed and then this column failed, or if this floor failed, what would happen? You can run these what if scenarios, and you can say if the fire was a certain intensity, what would happen? But you can't know exactly.
No, but in regards to the collapse in itself, when you look at the top down going down, and especially Tower 2 that was tilting, when it comes to mass in motion, isn't there a physical law that mass in motion goes where the least resistance is?
Yes, but in this instance, well, no, there isn't really. Mass moves in a way that is the result of net forces. Now, if you say something will move in the direction of least resistance, I mean, this ping pong ball isn't moving, even though there's no resistance straight up, and there's very little from side to side, but it isn't moving. I have a ping pong ball in my hand. If I remove what's underneath it, it will fall down. Now, if you got something, something being supported by something, and the structure underneath that collapses, is the path of least resistance then straight up, or is it to the left, or is it straight down? What we've got here is net forces. We have a force of gravity acting straight down. We don't have any forces acting left or right or up. So we've got the force of gravity acting straight down. We've got a resistive force from the building below acting straight up. If the force that's going upwards is less than the force that's going downwards, we have a resultant force which is downwards, which is going to be a bit less than gravity, but it's downwards. There's no reason for it to move from one side to the other. So saying the path of least resistance is kind of meaningless, because when you if you think of resistance as being a force, you have to add in gravity. And if the resistance is less than gravity, then that's actually the path of least resistance. In fact, there's actually force going down. Even though there's nothing stopping it going sideways, there's a force going down, there's no forces going sideways, it goes down.
But in regards to the force that's pointing upwards, the resistance of the structure in itself, and the force that is just enough to go down, you would still have that resistance, and that resistance is going to push it, because it's not a symmetrical collapse in any way. There is a point of collapse at some point, and wherever that point is the initiation, regardless of where that is. In my mind, and in people I've talked to that are architects and engineers here in Norway as well, completely independent of this, ask the same questions that I'm trying to ask here: is how would you then have a mass that is moving in that way, doing it symmetrically and continuing to do so all the way down, and not having one flaw left, and not even, for example, one of these engineers told me that if you look at demolitions of buildings, if you have one explosive that fails anywhere in that building, you will see an asymmetrical destruction of that building, where you will see exactly where that explosive didn't go off, because you had a lot more resistance there. So having a cold structure beneath and having that mass coming down, how does it not move over to any side? And for example, Tower 2 that starts to collapse, tilting, but it continues allegedly straight down on all the floors, and there isn't one floor left. Then you only have is a staircase with some firemen in it at the bottom. And in my mind, that is really a mystery. Why didn't it tilt off?
It seems unintuitive, but I think if you look into physics in general, there are a lot of principles of physics that seem unintuitive. Like you might not, why does a pendulum always take the same amount of time to swing? As pendulum of a certain length, regardless of how fast it's going, it always takes the same amount of time to complete one swing. It's not an intuitively obvious thing that would happen, but yet it does. It's an observable thing in physics. So with the top of building 2, now Tower 2, the impact was higher up than in Tower 1. No, it was lower down, wasn't it? It was lower down than in Tower 1. And it was a bit offset to one side. More offset than Tower 1, which was fairly central. And this caused a bit of an asymmetrical initial collapse, which caused the top of the tower to lean over to one side. But if something is leaning, that means that one side of it is falling faster than the other side, which means that the side that's falling faster is hitting the lower structure more rapidly than the side that is falling slower. So it's getting more resistive force on the side that is falling. So it will actually slow the rotation of that to a certain degree. But also the whole thing is just falling to pieces. It's not like there's just one big lump on top which is falling down and then, bam, 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 destroying each thing. It's a disintegrating building, essentially. That's disintegrating into these free-falling multi-ton girders. Now, if you imagine, like in the room you're in right now, if someone dropped a 20-ton girder on the top of your house or your apartment building from a height of like 30 feet, it would just go through the whole thing. And in the World Trade Center, you've got literally thousands of that type of thing going on all over, all different places. The structure that's falling is coming apart. The structure that is below that is also coming apart. The structure that's falling, that's coming apart, comes apart slower because there's more stuff below it that is also falling, hitting the stuff that's down below. But it's like someone dropped a bag of rocks on top of something rather than a single rock. It still does essentially the same thing. There's a video on YouTube where someone drops a bigger load of water on a car and the car gets crushed. Even though it's just dropping some water on the car from a height of 12 feet. Now, just because the water isn't a solid piece of something doesn't mean it can't do damage. So, you got to get away from thinking it in terms of, like cardboard box physics. It's not a box falling through something. It's girders and it's columns and it's concrete. And they're going through the floors, they're not going through the columns. It's much more complicated than, in a way you can't really use people get angry when I say this, but you can't really use Newton's laws of physics to describe a complex situation. If you look at Newton's laws of motion, Newton's laws of motion, like action and reaction are equal and opposite, a body in motion stays in motion, and F equals ma, force is mass times acceleration. They only apply in Newton's physics to point masses, and you can't mathematically apply them to complex systems, articulated systems. There's another set of physics. Laws of physics, which I think are Euler's, EULER, Euler's laws of physics, which are more complicated, and they include things like rotation. If you hit, you've got two things like this. One hits the other. It's hard to say action and reaction are equal and opposite because what happens to the two things is completely different. If you throw a rock through a glass window, sure, you could say when they hit, you've got these equal forces, but what's happening is a rock is smashing a window, which takes some of the energy away from the rock. So it's a lot more complicated than just there's something going down, there's something pushing up, and so they should cancel out.
But what you said there, that rock hitting the window and crushing the window, it does take away the energy and the momentum from the rock, and it does crush whatever is beneath. But that doesn't mean that whatever is beneath is going to continue the momentum after it's been hit and crushed. So you do have I just watched one of your YouTube videos where you tried to, demonstrate a braking effect of having this mass in motion. And you wanted to show that it didn't slow down. But in the video, to me, it clearly did slow down, but it was so small. It was slowing down so little that it was barely noticeable. Yeah. But in my mind, if you look at as an analogy, looking at the buildings as a fluid in motion, a fluid of building mass, and beneath it you have a steady fluid of building mass. And if you think of it in those terms, it just doesn't. That's not make sense, does it?
No, it's not a fluid below it. It's a series of connected objects. You can think of it as a series of rigid objects like girders and columns and concrete slabs. So the concrete slabs obviously get broken, and the other stuff is largely irrelevant in terms of discussing the collapse. But if you have a structure where if you take out a piece of it, the rest of it collapses. Just as an extreme example, like, you've got something that's like arranged like a house of cards, and you knock it a little bit and the whole thing collapses. You wouldn't think that is suspicious on the face of it. And with the World Trade Center, you require a lot more energy to start that progressive collapse. But once it's started, it's still the same type of thing. The building is essentially ripping itself apart. The floor panels hold the outer walls to the inner walls. The floor panels are on these little supports that are about this big. They're literally only 6 inches across, and they're like an inch thick, and they're 3 inches out.
From the center core out to the
like the little shelves like this, and then the truss rests on it.
I know.
Yeah, and if you look at the connections on the outer walls, they're very, very small. They've got these ties as well, but there's not a lot there. An actual floor panel in the World Trade Center is designed to hold the columns away from the wall. So it's got this stiffness in this direction horizontally. And it's designed to allow people to walk on it and to move furniture around and to store things. And they're designed to hold 6 times their own mass, these floor panels. Or 12 times, I think, is the maximum if you do it as a static load. Now, when you have something being dropped on those floor panels, it's very, very easy to imagine these floor panels just being stripped away from these little connections that they have on the outer walls. That means that floor panel is not holding the outer wall from the inner wall anymore. That's no big deal because you've got all the other ones. But if you start getting enough of them stripped away, then you've got these outer walls with obviously nothing holding them up, and they just fall away because there's all kinds of stuff going on. The inner core, much stronger with internal bracing, that stays up a lot longer. You see it in the collapses. You see the inner core not being destroyed, and actually half of it remains after the main mass has reached the ground, and then it collapses, which is probably because of the main mass kind of spreading out sideways as it hits the bottom. But it's not a case of something going down through something. It's a case of all these falling things basically knocking these floor panels off and pushing the columns sideways. The columns didn't fail from things dropping on top of them. That hardly did anything to the columns. They could have probably supported the random things that happened to fall on top of them. What happened was they lost the lateral support, which means that it was then very easy for them to snap at their seams. They had these seams which were welded with very, very strong welds, but when you're talking about tens of thousands of tons being suddenly applied sideways with leverage, then these things just... Most of the column pieces that were found in the rubble of the World Trade Center were straight. You see a few pictures of the ones that are the famous ones, like the one in the memorial that's got that big bend, and then there's another one that's kind of like a big C shape. But the vast majority of the column pieces from the World Trade Center are just perfectly straight. And you look at the ends of them, and you see that the welds have just popped out. And this is because they fell apart because they were being pushed sideways. So the force to do that is nothing at all to do with their supporting force. It's all to do with the building basically falling apart.
So what we're actually watching then, in your view, is that what is actually collapsing on top of the floors is part of the top core of the building, and it's a lot more. It's been disconnected completely and let loose, and it's a lot more weight and amount of force let loose from those columns hitting the floors below, because those, as you say, those columns were so strong and big that they could basically rush through everything. But what I'm wondering is, in regards to when the collapse is starting and the initiation of it begins, I would imagine a building fire in that way twisting and morphing the building over time. And you would see it, and
you could actually see it. The reason you can't see it, that you think you can't see it, is that the building is very, very, very large. So you're actually getting deflections of several feet in various places, and these are things that you can see in the NIST report, like the wall is being pulled in on one side, and you can see there's a deflection. I think it's like 6 feet or something. It's quite a significant amount, and then it all kind of comes in at once. But yeah, you are getting these warpings, these local warpings of things. But the fires really weren't hot enough to melt the steel, so it just turns into like a spaghetti noodle. They were hot enough that it lost its strength and it would slowly sag and bend. Most of that happened inside, and this is what's responsible for the curved columns that you see. But the building structure is fairly rigid. You've got all these floors attached to the core, and then you've got the hat truss on top, which is this big structure that sits on top of the buildings that was there mostly to hold the antenna up, but it also gave a lot of structural stiffness to the buildings. So when one column loses its strength, it will sag a bit, but the weight from that one column being carried by that one column gets transferred to the other columns around. So it's not like that fails and then all of a sudden it gets squished into nothingness. It fails, it will like maybe bend a bit, or it will like get compressed a little bit, and then because it's not capable of supporting any weight, it basically doesn't exist from the building's point of view, and the building sags a little bit more and a little bit more and a little bit more. But eventually, what happens is the accumulation of all these things means that there comes a point where something fails, some column fails, the building, it doesn't try, but the building structure redistributes a little bit, but this time there isn't enough strength to stop it. It's reached this tipping point. So that fails, something else fails, something else fails, something else fails, very, very rapidly, bam! the entire thing fails across like a wide section of that building, and then
But
the collapse starts.
the spaghettification that you mentioned there, wouldn't you see that very visually out even outside the building that if there is a gradual heating of the core and of the columns and of the building and of itself, wouldn't you see it almost sag onto itself and thereby actually
No,
just stopping?
no. If it had done enough to sag onto itself, that would mean the entire structural integrity of the building has failed, and it wouldn't be able to support itself.
It just doesn't make sense to me because you have basically
You
three
would have to. The
individual
only way you could
buildings
do
within.
that is if you evenly heated up everything and had everything perfectly balanced and had it all coming down.
Yeah,
If the top of the building starts to go to one side, then that means that the forces are pushing down sideways essentially on the things below them, and
yeah.
they're only designed to. The building is designed to be perfectly vertical. Once
Mm,
things start to not be perfectly vertical, yeah, it's kind of game over. You've got
mm,
you've got forces on the columns that they were not designed to hold. You've got forces on the walls that were not designed to hold, and so it's going to start coming apart. And you've got to remember how big this building is. When you're looking at things, you can't compare it to a smaller building. It's 200 feet by
mm,
200 feet, and 1,300 feet high. So it's an immense building. So you
mm,
are seeing these effects of things, metal giving way and the building sagging a bit, but
mm.
it doesn't look like very much from far out. But look at the NIST report and the images where they show the deflection of the building, and they show other things like internal floors that have fallen, and
Mm.
they will discuss how the hat truss and the columns redistribute the load. But eventually you get to a point where you can't redistribute the load. Um,
Mm.
People laugh at the example of a can. When you stand on a can, you weigh I weigh like 170. I can just about manage to balance on this can. Probably not but just about. When
Mm.
I weighed 150, I could balance on a can.
Mhm.
But all you've got to do to make this can collapse
Yeah.
is just do a tiny little thing, and that
Mm.
one failure immediately propagates around every single bit of the can.
That's a
Um,
good example.
yeah, it. People don't like this example because they say, "Oh, well, a can's, you should put one can on top of another can." But then you start having to get into the details of explaining the square cube law, where as things get bigger, their strength increases as a square of the size, but the weight increases as a cube of the size, which is another complex physics phenomena that is difficult to explain to people, and it's not intuitive.
It's too
So
complex for me.
that's well, that's how. There's a famous analogy where if you're dropping animals down a mine shaft, which is something that happened in the past because animals would wander into mine shafts, and then they would find animals at the bottom of these mine shafts, and they would say I think it was like a mouse bounces, a dog breaks, and a horse splashes. So you've got
Yeah.
similar types of things. You've got animals, but because one of them it's like 50 times as long, that means it's 50 cubed times the weight, but the actual strength of that thing is only 50 squared. And the reason it's a square is that it's proportional to the cross section. If you think of a pen, something like this, the strength of this pen isn't anything to do with how long it is, but how long it is related to what it weighs. The strength of the pen is only related to the cross section. So it's
Mm.
only related to the square of the subject. But this is a challenge that I have in explaining things to people. Square
You should
cube law
put.
is not intuitive,
Is there any
and
models of this that are easy to explain?
the square cube law.
Yeah.
There's a good example of it in use on the thread in Metabunk on building a physical model of the World Trade Center. I can't remember the exact link, but I shall give it to you and put it in the description. But
Yeah, that'd be
this
awesome.
Chinese company wanted to simulate a building in an earthquake. So they built a scale model of the building, and it was a 1/10 size scale model. And so the original building was, over 400 feet, and they built a 40-foot high model, which is pretty impressive. And they put it on an earthquake table, which would simulate a magnitude 9 earthquake. And they built this really nice scale model. It was basically of like Meccano type things, these little metal bolts and metal pieces and girders. But then, in order to make it realistic, they then had to add about 9 times the model's weight in lead bricks, which they put on every single floor to make it realistic. Now, people who think that if you just simply scale something, that would work. People think that if you scale it, you can just do a test on that thing, and that thing scales to a larger thing. But if they'd taken this scale model without these lead bricks and just shaken it, it would have been fine. They could have done a magnitude 12 earthquake, and it would have been perfectly fine because of the square cube law. So they had to, because its size had been reduced to 1/10. They couldn't reduce the size by 1/10. They had to reduce the weight by a proportion which is I think it's the square root of 100 divided by the square root of 10, something like that, which would be 10 over 3.
So the size of the object in and of itself, regardless of how you're modeling it, the size will always change the behavior in regards to the reaction to the physical, that the building would react differently.
Very differently.
Yes, regardless of what you'd model.
Yeah, with a scale model, like I have a scale model of the World Trade Center. Right here. This is about a 1 foot, so 1/1300th of the actual scale size of the World Trade Center. And yet this scale model is vastly stronger than the actual World Trade Center model. Look, I can take this model and I can drop it from a height of its own height, and it lands on whatever, and nothing happens. I can throw this thing, which is the equivalent of thousands of tons in scale, and it just bounces off. Yeah. Because very, very small scale models are very, very strong. Now, if I was to scale this and make it the right weight, it actually would be impossible in this universe. It would be denser than the densest known element in the world. If you had a scale model of the World Trade Center Tower that was 6 feet high, I think if you made it out of solid gold, like it was a 1 foot by 12 foot solid gold cuboid, that would be about the right weight. So you can't actually build a scale model of the World Trade Center and simulate it exactly, unless you build it. You have to build it over 100 feet high and add all these lead bricks
but you've done
make
that
it work.
With your videos, and
yes, I've done it with wood, and what I'm doing there is I'm demonstrating one aspect of the collapse. I'm not demonstrating the entire thing, because if you look at my thing. The model I do, none of the floor panels break up. There's very little in terms of dust or anything like that. I'm not simulating the actual collapse. Nothing really breaks. There's no strong connections between things. And what I'm simulating there is when a floor panel can only support 6 to 12 times its own weight, and you start a collapse by just offsetting the top of the building a little bit so it falls out of line with the columns, then the entire building will collapse. So it demonstrates that one aspect of it. It doesn't demonstrate how exactly that happened in the case of the World Trade Center. And you can't do it with a scale model. You have to do it with a model that replicates some of the conditions. So the condition I chose to replicate was the floor panels support 6 to 12 times their own weight. And I tested that by putting 6 floor panels on one of them and doing 12 very carefully, or dropping 6 from a certain height. But I also did things like I threw a spanner, a wrench, at the side of the building, and if it had been an accurate scale model, then that wrench would have just gone right through it the same way the planes did, but it just bounced off. So it's obviously not a perfect scale model of the World Trade Center, except in that one aspect, the one aspect where you've got these panels which can only support a certain amount of weight, and when they fall, the buildings fall. So.
With I totally see what you're saying. But in regards to the building changing and morphing during the before the collapse in and of itself, wouldn't you see windows breaking all around the building gradually, like completely, with the building changing that much in its symmetry? Wouldn't you see that as that
Which
it would just
building
be
are
breaking?
you mean like
Oh,
the towers?
both of them. Oh, well, both towers. That you would basically see windows breaking if the building was actually twisting and changing in regards to.
Well, you can look at it wasn't twisting. I wouldn't say it was twisting at all. It was sagging in some areas, and the outer walls were being pulled in a little bit. And it really wasn't sagging in a way that's noticeable. Like I say, the load transfer would go to the other things, and that they're still holding at the top of the building, but an individual column will have sagged, which means that like a floor will start to sag a little bit internally. And you can see there are photos of these bowed floors internally. Now the exterior of the building has all these columns, and obviously a lot of them were missing at the time, so it's there's a lot of damage there. But you do see this inward pull of the face of the building, and you see a bowing of the entire building over several floors. Now, why doesn't that make the windows break? Well, it's because it's the actual angle that it's doing isn't that much. It's like someone took the bottom of a window and they pulled it in like 3 inches, and then the window below that got pulled in another 3 inches. The window below that got pulled in another 3 inches. It wasn't like it just like twisted the entire structure. And I think there were a few windows that were broken, but the windows on the exterior of the World Trade Center were obviously designed to be very strong, like withstand hurricane force winds and people falling against them and things like that. So it just didn't break because it didn't bend that much.
Well, people did actually break those windows at the top themselves, though.
That's pretty impressive. Wonder what they used.
Yeah, but just being able to breathe at the top. I mean, that they actually managed to do that. If the building, I'm just thinking about how, they can't have been that strong if they. But anyway,
they could smash it with a fire extinguisher or something very heavy. Or, I don't know.
For example, there is when they did the heat mapping of the buildings after the collapse, you could see identical heat signatures from all three buildings.
Well, I wouldn't say they were identical. They were different shapes. They were about the same temperature.
Yes, of course, different. Yes, exactly. They were same temperatures, and but the same type of signatures in regards to, basically showing that something was really hot, and it's been hot for quite a while.
The thing that was really hot was fire.
But how do you sustain fire underground that way, where there's basically not much oxygen or anything to?
Those photos were taken, I think, like 2 or 3 days after the collapse, so it wasn't that far into it, and they cooled down pretty rapidly after that. Obviously, there were fires still burning for like over a month in the World Trade Center, and there were reports of pockets of very, very hot regions. But the Avarice data, which you're referring to, essentially shows fire. Now, there are some other hotspots that aren't in the World Trade Center site, and they mention this in the description of the Avarice image. This was an image done with this multispectral camera, which they flew over. I think it was a Navy camera. And they say, the red spots outside the World Trade Center site are heating system vents. So you were getting these red spots in New York City that were not much cooler than the yellow spots in the World Trade Center site, and that was simply just from the exhaust from heating systems in buildings. And an actual fire itself is very, very hot. The flames are very hot, and what it's measuring is the temperature of those flames and those gases coming out. It doesn't mean that all the metal underground has been heated up to 1,000 degrees centigrade or anything like that. It just means that there is a fire. And if it was just a big bonfire down there, it would probably actually look a lot hotter. It looks kind of patchy because it's largely underground, and what you're seeing is the hot gases coming out and heating things in that immediate area. So I don't think that is very suspicious, and I also don't think it's evidence of thermite burning, because if there was thermite burning, you would have to have thousands of tons constantly burning for it to keep it up on, because thermite burns very fast, and it contains its own oxygen, so it would just all burn up. Whereas the rubble under the pile doesn't have its own oxygen, so it just burns as it gets uncovered or as oxygen comes through. So you have this kind of smouldering fire, quite intense at first, but eventually smouldering.
Interesting theory. The fires, though, I'm quite sure weren't put out. The last fires underground weren't put out until Christmas.
That sounds about right, actually.
So they were burning for months, but
which is not unprecedented. There are lots of sites where fires have burned for months. For example, rubbish dumps is a very common place where a fire gets started and it can burn for months. And obviously, like abandoned coal mines, but you kind of expect that. But it's the same type of thing. There's a source of fuel which is underground, which is slowly burning or quite intensely burning if it gets a lot of oxygen. If you actually think about how much combustibles there are under there, and how much is burnt, it's not.
But the building's burning in the top sections. But the top sections being, in my mind, what would probably lay on top after the buildings had collapsed.
Well, there were still several floors. I think 13 in the case of World Trade Center 1, and some more in the World Trade Center 2 on top of that. So if you're going to be thinking of it in terms of a fire sandwich, you've got this huge amount of debris underneath, and then you've got the fire floors, and then you've got the floors that were not on fire on top of that. But the whole thing kind of gets mixed together as it falls. And fire isn't something where there's a fire up there and it gets transferred down here. All kinds of things start fires. And there was thousands of individual little fires in the pile, which can then spread to other things.
Yeah. But the testimony from the fireman and from the one of the emergency scene chiefs, can't remember his name, but he testified to the fact that there were underground molten steel, and that the intensity of these fires was so hot that it was like opening up a box with lava in certain places. Have you explored these subjects?
Yeah, and I think what they saw almost certainly was not steel. Molten steel is ridiculously hot for a start. If it's molten, if it's flowing, it's hotter than the hottest steel you've ever heated up with a blowtorch or something. It's actually white hot. And there's two things because it's white hot. One is it cools down very quickly. Molten steel does not stay molten very long. Because it is so hot, it's basically radiating, conducting heat away very, very rapidly. The hotter something is, the quicker it cools down. There's this very steep curve of things cooling down. Molten steel is also so hot, because it's molten, that it sets fire to everything around it and burns everything around it. So it becomes very, very energetic. If you've ever seen a foundry accident where they spill the steel on the floor, it's like sparks going everywhere. It's a crazy thing. So I think what they describe doesn't really fit molten steel, which is this white, hot, highly energetic material. It more fits something less energetic, like molten aluminum or molten lead. There was lots of lead in the building from a variety of things, like uninterruptible power supplies. They had lots of batteries in the buildings and various other things. It could even be molten glass, like glass. I can't remember what the temperature of molten glass is, but if something like that is melting and flowing. Or it could be like aluminum with a bunch of embers on it. I think this is what actually happened with the golden things that you see flying from the building earlier. Is it's molten aluminum, but it's carrying out the fire with it, so it's carrying out all these embers.
The sparkly stuff that goes down.
Yeah. If you look at that very closely, you can see there's actually a bunch of dark things falling as well, which I think are the actual just aluminum without the embers in it. But I think the stuff underground, people saying they saw a river of molten steel, I think they meant essentially they saw a river of molten something that kind of looked like metal. They didn't know if it was metal. They're just assuming it's metal, and they just said steel because that's the first metal that came to mind. Because firefighters don't generally come across rivers of molten steel. So would a firefighter know what a river of molten steel looks like? Yeah, you could argue that they should because they're fighting fires, but since you don't get molten steel in the vast majority of fires, why would a New York firefighter be familiar with what a underground river of steel actually looks like? When it doesn't actually look like what they described, because if it was molten steel, it would be exploding everywhere.
Yeah. There's been quite a lack of images and videos of it as well. But
and that's the other thing. They didn't find these lakes of steel. If you've got a river of molten steel, and these rivers have been flowing for weeks, then you're going to have this huge lake of molten steel at the bottom of the building. That's just like this pure steel because everything's going to float on it, they didn't find anything like that. You don't see that in any of the recovery photographs. You don't see these. You see like barely melted guns and things like that.
Yeah.
You don't see melted steel. You don't see beams where the end has been melted off. You don't see like something like with a puddle of steel. Like even if you had 100 pound or 1,000 pounds of steel, which is like a bit of a girder. Where is it? Where is this big vat of steel? Where did it end up?
But you do have something that resembles the something of a volcanic rock mixed with molten metal and different sorts of items, and even molten concrete that's at the museum, if I'm not misremembering.
Yeah, there's a thing called a meteorite, but if you look at that, there's actually bits of paper in it.
Paper in it?
Yeah.
Really?
Yes.
Oh, I'll have to check that out.
So really what that is, it's a compressed chunk of the building. When the building fell, some parts of it were in regions where they had thousands of tons of stuff directly pressing down on them, obviously, because they were at the bottom of the pile. And they were in a fire region, so bits of them got scorched or whatever. But if you look at the thing you're referring to, the meteorite, you see it's got all these bits of iron and steel coming out of it, which are not molten, they're just regular steel. Then it's got concrete, which is essentially just compacted concrete, and you've got some burn marks on it. And if you look very closely, you can see there are bits of paper with visible writing on them.
Paper inside the meteorite rock. I'm going to have to write that down and actually check that out, because that's interesting.
Debunk it if it's not true. You've been listening to Tales from the Rabbit Hole. I'm your host, Mick West, and my guest today was Stian Arnesen. This episode ended a little abruptly because I excised it from a larger episode, which you can listen to in episode 3 if you missed that one. Very interesting stuff. Find out more at TFTRH.com.